Hello, everyone. Welcome back to day 2 of SpringOne 2020. I'm Brian Lyles, Senior Staff Engineer working with Kubernetes at VMware.
And I'm Ben Wilcock, Tech Marketing for Spring at VMware.
Well, thanks for joining us for our third and final round of conference keynotes. This morning's theme is Cloud and Platform. But first, here's how you can participate in the conference today.
Absolutely. So do get involved. There are 2 really easy ways you can do that. First of all, sign up for the conference Slack at springone.slack.com and join in the session Slack channels as well. And second, you can get in touch with us on Twitter. So we're at SpringOne, or you can use the hashtag SpringOne.
Thanks, Ben. Who's up first?
First today, it's my great pleasure to introduce Craig McCluskey, VP of R&D here at VMware. Craig is the co-founder of Kubernetes, and today he's discussing the evolution of operations with the help of some very special guests, Bosky Savla and Grant Shipley. So you'll want to go full screen for all of the demos today. They're all really good. They're definitely worth it. So let's cross over to Craig.
Hi, folks. My name is Craig McCluskey, and I'm extremely excited to have an opportunity to speak to you today. During yesterday's keynote, we heard how Spring is fundamentally transforming Java development for enterprises, how the work that we're doing in this community is emerging as a staple for enterprise Java development. Today, I'd like to take a little bit of a different tack and talk about the evolution of operations. When you look at the industry as a whole, there's been this really exciting trend that we've seen starting to take hold over the last years. And it's really an evolution about how work is done inside organizations. If you look back historically, the primary unit of work when developers were interfacing with centralized IT teams or operation teams was the ticket. So the world was ticket-driven. And increasingly, with the advent of cloud technologies and more practical infrastructure abstractions, we're starting to see this move where the atom of work, the unit of work that developers can rely on, is the API. And obviously, there's a burgeoning set of technologies that bring these 2 worlds together, that pragmatically match what developers are trying to accomplish from an outcomes perspective with a way to drive the infrastructure into the desired shape to support those outcomes. And this really represents an interesting fusion of the worlds, the developer platform worlds, but increasingly the infrastructure worlds as well. And if you've been an attendee of SpringOne for some time, you will have seen a number of customers stand up on the main stage, obviously a physical stage rather than a digital stage, and talk through some of those experiences. And when you look at the experiences of all these customers, one thing stands out. They've been able to use the power of Spring and developer framework technologies that have been driven into an infrastructure environment by intelligent systems like the PaaS system, what's now called the Tanzu Application Service System. And as we look to the future, we anticipate that this will continue. And when you look at the core of this whole outcome, like what's driving these experiences from a developer's perspective, it's really about being able to create a superhighway from the developer's IDE into a production environment, enabling developers to have a fully curated set of dependencies, tools, everything they need to be able to produce the business outcomes. And it's really interesting. When I spend time with organizations out there in the wide world that are at varying points in their IT journey, it's always interesting to ask the question, how much of your time do developers spend actually developing that is capturing business logic and code and solving real problems that are advancing your business versus engineering? That is the amount of time they spend setting up the environments, whether that's pre-production or their own local development environments or the production environments, worrying about how to set up continuous integration delivery tasks, sweating the details about how their code ends up in a production context. And for most organizations, it's unfortunately disproportionately weighted towards that engineering factor. And the work we're looking to do here is to change that, really enabling developers to focus on the thing that is driving the business forwards. And the root of that, from our perspective, has always been the CF push experience. How do we create that superhighway? To be able to accomplish this outcome, not just for the set of applications that fit well into the 12-factor patterns that developers have been using, but to think about it more generically. We need to ensure that we're supported not only by a set of agile practices, but that those practices are supported by agile infrastructure primitives and the technology that's able to make the best use of them. Now, if you look back at my sort of experience, I've obviously been a huge fan and advocate for Kubernetes. Kubernetes is a technology that effectively abstracts away the infrastructure, allows a variety of different infrastructure environments to look and feel consistent, and solves the problems of living with an application in a production context. But it's always had challenges from the experiential perspective. How do we bring that really clean experience into that environment? And I've been so excited to be a part, a very small part, of working on bringing that CF push experience into the Kubernetes ecosystem. And what I'd like to do is just peek under the covers a little bit and articulate what exactly is happening here. Why is this so exciting? And I think that if you look at technologies like Kubernetes, it's become not only a destination for building and running distributed applications, but it's also become an environment in which we're seeing a tremendous amount of additional innovation. We're starting to see the emergence of service mesh technologies. We're starting to see the emergence of a lot of other adjacencies that support these outcomes. And what we're working to do with the work through the Cloud Foundry ecosystem, with the initial beta of the Cloud Foundry experience on Kubernetes, is really bringing these worlds together into an incredibly coherent and valuable form factor. So now let's look at what this feels like, what this looks like, and what you can expect from the bringing together of these two technologies. And I'd like to hand off to Bosky, who will walk you through that.
Thank you, Craig. And now we are going to take a Spring Boot application that uses Spring Data Services and see how Cloud Foundry is going to help us deploy that application into Kubernetes. Now, because Cloud Foundry is working with Kubernetes, it is going to simplify the overall developer experience by automating a lot of the tasks that a developer has to go through in order to deploy an application into Kubernetes. Let's take a look.
Now, to begin with, I have Tanzu application service for Kubernetes deployed on a Kubernetes cluster. This is the dashboard of that K8s cluster. I'm using Octane to visualize all my objects here. So you'll see the cluster has 5 nodes right now, and it also has some persistent volume. And it also has Cloud Foundry components installed. So you'll see namespaces like CF system, CF workloads, etc. And these namespaces essentially hold the Cloud Foundry component pods and containers within those namespaces. So the CF system namespace is going to hold all the Cloud Foundry components. And then once we start pushing our applications for this Kubernetes cluster, you'll see them rolling up into the CF workloads namespace. So let's take a look at the CF system namespace. Now you'll see that this particular namespace has all the CF API server, Arini, Fluentd, etc. running on it. And this will be the API that we talk to using the CF CLI. Now let's take a look at an application that we want to push to this Kubernetes cluster. So for this demo, I'm going to use Pet Clinic, which is a Spring Boot-based app that needs some services and dependencies. We already declared that in our pom.xml file. Particularly, it needs a SQL service to store data into. And once we have, I've declared that dependencies, I've also created a manifest file, which basically tells Cloud Foundry what name to use and where is my executable tar file for it to package up. Over here, I've already installed my CF CLI, and I am pointing it to the CF API that's deployed within that Kubernetes cluster. And I'm already targeting a particular org in space within that Cloud Foundry environment. Now, to deploy this application, all I have to do is just push the app. So I'm going to do CF push. Now, in the backend, what's happening is Cloud Foundry is going to package up this jar file and all the dependencies it needs, create an OCI compliant image for us, and store that image in a registry, and then deploy that application as a pod within the CF workloads namespace. Right now, the Pacato build packs, the Java build packs are going to build that app for us. Right, so the application has been deployed, and what I want to do now is create a SQL service and bind this application to that service. So I'm just going to create a MySQL database service using a service broker that's installed on that Kubernetes cluster. Now this will take probably a minute or two. What's happening in the back end is that Kubernetes cluster is going to create a persistent volume claim for this particular database service and then bind that to a pod that will be running, that will be accessing that particular persistent volume claim. Let's make sure that the service is up and running. So I'm going to just do CF service, pet clinic. It's created the service, and now I simply bind my application to this particular service. So I do a CF bind service. All right, and now if I restage my application, it will start using or consuming that SQL service. Right. So while it's doing that, I want to take a look at Kubernetes cluster and see what's going on in there. Now let's take a look at that MySQL service. So I'm going to buy service broker namespace, and you'll see that there's a MySQL pod created. And this particular pod has some secrets, deployments, and persistent volumes created for that. So let's take a look at the persistent volume claims. You'll see that this particular pod is using the particular PVC that was automatically created. In this case, cluster by CF CLI. And you'll see that this particular pod has the persistent volume claim automatically attached to it for our MySQL database. Now, if we go back to our CF workloads area, and look at the pods that are deployed over here, you'll see that now there's a pet clinic pod running with 2 container images. One container is actually the application itself that is packaged up, the jar file, and then the other container is basically the ingress or the Envoy sidecar so that we can route traffic to it. And notice the CF or the Cloud Foundry actually automatically created the stateful set, a secret, etc. for this particular pod, so it understands how to talk to the SQL service. So now let's take a look at the application and the route that it got. So this is the ingress route that it has, and I'm going to go ahead and hit that on my browser. You'll see that this application is running, and we can get to it from our browser. So in summary, if I had to deploy this particular application directly to Kubernetes, I would have to write my application code. Apart from that, I would have to create container images, create a Docker file, build those images, tag them, push them onto my registry. And then once I have everything, I would have to actually make sure I have the corresponding Kubernetes YAML file created, for example, for the deployment type, for the service type, for the secrets, the config maps, etc. I would have to similarly do the same thing for my database pod that that particular app is going to talk to, and make sure that it ties to that particular application, and then finally deploy all of this into Kubernetes. Instead, if with Cloud Foundry running on top of Kubernetes, what I have done instead is created the app, did a CF push into that particular Kubernetes cluster, created a service using CF create service, and then tied that or bind that service to that particular app. And all of the backend operations of creating config maps, secrets, persistent volume claims, etc., all the necessary Kubernetes objects and YAML files have automatically been handled by Cloud Foundry.
Thank you for watching this, and make sure you check out all the Task for K8 sessions.
Thank you, Bosky. Now, as you can see, what we've worked to do with the CF community is to bring that superhighway experience into a production environment. But one of the challenges that exist out there in the industry, and this has existed for a long time, is that while those high-level abstractions create tremendous amounts of opportunities to optimize the development experience, you always encounter these experiential cliffs. There's always something that doesn't fit naturally into those frameworks. And so as we think to the future of innovation in this area, something that we're really invested in is raising the watermark, providing a set of modular and composable pieces that can be pulled together to deliver those experiences for a much broader array of workloads. And what I like to say is, you always want to use the highest abstraction first. As a IT team making decisions, or as a line of business team making decisions around which technologies to use, encouraging developers to use those higher level abstractions first makes a tremendous amount of sense. But there's a lot of work that we still need to do as a community to make those experiences applicable to much wider array of workloads, to enable within verticals, within specific industries, the ability to pull that together to create a coherent experience. And so when I look at Tanzu, the mission behind the work we're doing here is to foster innovation and make that innovation accessible to developers everywhere. That really provides the glue that ties together those experiences, that enables you to create that platform experience that's tailored to the specific workload that you need to deal with on a day-to-day basis. And with that in mind, I'm incredibly excited to introduce the VMware Tanzu Build service as a new offering that is now generally available. And the vision behind that is to distill out capabilities that Taz has offered historically to securely construct a packaged Spring application and make it accessible for deployment into a wide array of contexts. This is a challenge that industry has had for some time, something that I believe that Taz has done uniquely well. And our intent behind this is to modularize it, make it accessible so that it can be used by itself, to genericize the capabilities so that you can fit it into other factors, and ultimately democratize it so more developers can use these powerful capabilities to bring their Spring applications into a production environment. And so ultimately, we see Tanzu as glue. It's pulling this all together. And when I look to the future, it's really interesting to see where this might go. A great example of this is the ability to construct functions. Meaning, if you want to run a small amount of code at the other end of an event, you should have that ability. And that should be a natural part of your tool chest as a developer. And when we start thinking about Spring and Graal VMs and some of the innovation that's happening in Kubernetes and in Kubernetes adjacent efforts like Knative, we're now able to bring this all together in a coherent way. I'm excited to introduce Grant, who will be talking you through what this experience looks like.
Thanks, Craig. I'm super excited to be here today to show some of the great work we've been doing over at VMware in relation to Kubernetes and making it accessible to Spring developers. To showcase this, I'm going to be running through a demo scenario showing a path to production. And we're going to be leveraging the work that Sebastian and team did that you saw in a previous demo to take a natively compiled Spring Boot executable and running it all the way through a CI/CD pipeline and deployed into the native Kubernetes cluster. Let's get started. Let's start our demo journey using Tanzu Mission Control. Tanzu Mission Control is a software as a service offering provided by VMware that will allow you to create and manage Kubernetes clusters. Let's go ahead and create a cluster for our development demo today. To do that, you click on Clusters and then Create Cluster. I'm going to be deploying this to AWS, and I'm going to give it a name of Spring Development. You can also select a cluster group for this to be a member of. This helps with organization and applying policies. I'm going to click on Next, and I can select the region that I want this cluster to be deployed to in AWS. And then I can select the control plane type that I want deployed with my cluster. You have the option of deploying a single node control plane, which is great for development. And you have the option of a highly available control plane, which is what you'd want to use for production. You can also select the machine sizes. I'm going to go ahead and click on Next, and then you can specify the number of worker nodes. This is the number of nodes that will actually hold your applications. After you do that, you simply click on Create Cluster, and Tanzu Mission Control will go off and do all the work to deploy this Tanzu Kubernetes Grid cluster for you. Now, it takes about 10 to 15 minutes for this process to complete. So for the interest of time, let's fast forward to when this cluster is actually completed. While the cluster was creating, I went ahead and I git cloned the famous Pet Clinic Spring Boot application to my local machine and opened it up in my IDE, Visual Studio Code. Let's go ahead and change a couple things. The first one will be the messages.property. Let's just say welcome to SpringOne. And let's also change a class file. And we'll just system.out.println hello from the controller. And we'll save those changes. So now that we have made all of the changes to our application and we're not embarrassed by our code, we should probably go ahead and commit it up to the Git repository to let our CI/CD system pick it up and deploy it into a different namespace in Kubernetes. One of the great things about this CI/CD pipeline that we're getting ready to execute is that it takes advantage of all of the work Sebastian did and showed you in a previous demo, and that it's going to build a container image and it's going to compile this Pet Clinic application using GraalVM. And this is going to provide us a lot of features, such as a low memory footprint and lightning fast startup times. So the way we trigger this pipeline is actually via a pull request. We can see that we have two changes here. So I'm going to check these changes out to a branch, and we're going to call this SpringOne demo branch. And then I'm going to commit these two changed files that we've made as part of this demo. And I'll just say update. And it's going to ask me if I want to stage my changes. I'll say yes. And so then we want to push this up to our Git repository. So let's go ahead and select push. And then we want to publish this branch. And so now we will quickly pop over to our Firefox web browser, go to our GitHub repo. In this case, it's github.com/Shipley SpringOne. And we should see that a branch has recent pushes. So let's go ahead and create a pull request for this. And so this would be if you're doing a code review and you want to see the code running. What's great about this pipeline is that as soon as I create this pull request, it's going to trigger the pipeline event. And this will run through the CI/CD process and deploy the changes made in this pull request inside of a container so that my team or other people could look at the changes. So let's go ahead and create this pull request. And then let's open up the Tecton dashboard that was deployed as part of our Kubernetes cluster. And you can see that we have a Pet Clinic native pipeline run happening. And this is going to run through and build the code. And at the end of this, we're going to have a new namespace created. And it's going to be running the GraalVM compiled version of the Pet Clinic application to allow others on my team to check out those changes. So let's go ahead and let this build process run. As you probably learned in Sebastian's demo, it does take a bit longer to build down to a native application using Spring Boot. One of the great things about this pipeline is when it completes, we've also added a trigger in that it will update the GitHub conversation for this pull request with the URI to look at the changes as it's deployed inside of a container on Kubernetes. Now, also, we're taking advantage of Knative serverless and scale to zero functionality inside of this pipeline. So what that means is we're taking advantage of all of the GraalVM benefits that we get, like low memory footprint and lightning fast startup time, to deploy this as a scale to zero. And so let's illustrate this using Octant, which is the dashboard for developers. So if I look at this namespace, we only have one pod running right now, and that's the MySQL database. Now, keep in mind, the pipeline also deployed this MySQL database and configured all of the database information, such as username, password, things like that, in order to connect to it. So let's go back to our GitHub and let's copy this URI, and let's showcase this by moving this to a split screen scenario. So I am going to paste that URI in, and what you'll notice as soon as I hit enter, the scale to zero with Knative will take effect, and it'll actually scale that container up, and you can see how fast the startup time is for this and how fast its service requests. All right, I'm going to hit enter in 3, 2, 1. I just hit it. We can see that the container is spinning up and it's already serviced that request. Look at that startup time. and the ability to service these requests in a scale to zero fashion. It is truly game-changing in that we can use Spring Boot for serverless functions and other scale to zero scenarios now. So let's bring this all together at the end with an added feature that was deployed on top of our cluster as we deployed from Tanzu Mission Control. And that is the ability to add observability to your applications and to your cluster. And we do that via Wavefront and Tanzu observability. So let's go ahead and close down the Octant dashboard and go to the Wavefront dashboard inside of Firefox. And I'm going to select to view the Kubernetes dashboard. And let's select our cluster. And we can see that we have 3 nodes running. And then we can drill down into specific namespaces. So let's look at that scale to zero deployment that we just created. And we can see that we have the actual pet clinic deployment running right now. And then we also have the MySQL database. And so if we click on that database, we can get information such as CPU usage, memory page faults, things like that. Just a plethora of information available to us. What's also critical is the application observability that's built into the platform. So if I go to application status, we can see that we have Pet Clinic. So let's click on that and let's look at the traces. And so I can dive right in and start to get some observability onto the application that we've deployed. So that wraps up our demo journey where we went from a integrated development environment using Kubernetes all the way to a path to production using CI/CD pipelines, taking advantage of Graal VM and Tanzu Mission Control. Thank you. Thanks everyone for your time, and I'll turn it back over to Craig.
Thanks, Grant. Now, the future is bright. I'm extremely excited to have this opportunity to bring the world of infrastructure technologies and participate in stitching that together with incredibly powerful and relevant technologies like Spring. And I think if we look to the future, this is going to create tremendously differentiated outcomes for our customers and for enterprises as a whole. It's going to mean that we have much more determinism in terms of how applications are being built and delivered into production contexts. It means that as we bring these technologies online, the role of the operator is going to evolve so that they're able to deliver a set of services rather than having to serve tickets on a day-to-day basis. And ultimately, I see the fusion of these environments of the world of developer platforms and the world of these polyglot technologies like Kubernetes or Knative as driving the next wave of innovation for IT. And what I believe the outcome of this will be is ultimately the ability to think of development as participating in a secure software supply chain, having developers empowered with tools that they know and love, that they're able to use on a day-to-day basis, but resting assured that they're supported by technologies that ensure that that delivery is safe and secure, and enabling them to really focus their day-to-day life on capturing that business logic in code, rather than having to worry about the details of how that code is getting into production context and the mechanics of operating that on a day-to-day basis. To continue this conversation, I'd invite you to attend some really exciting breakout sessions that are coming up. Stefan and Brian are doing a session on Spring Boot Loves Kubernetes. Ben Hale is doing a talk on Spring to Image that is well worth catching. And Deepa and Ramiro will be talking about Tanzu Service Mesh from the developer's perspective. I think all of these sessions are relevant to the conversation we just had, and I'm definitely excited to continue this journey with everyone here. Thank you so much for your time.
Thanks, Craig, Bosky, and Grant.
Hey, Brian, I think Bosky was using Octant there, right? You work on that, don't you?
Well, I work on it, and I also created it. It's a tool to help people understand what's happening in Kubernetes and what might be broken in Kubernetes in a visual way, because not everybody wants to use the command line. But we're not here to talk about me today. What's going on Twitter, Ben?
Twitter, right? Let me just have a quick check. Yep, definitely true. You're still 20,000 more followers ahead than I am. So yeah, clearly I need to get working on some open source.
Yeah, good luck with that. But really, follow Ben on Twitter. You can always unfollow him later. So Ben, who's our next guest?
For our next guest, we have Dr. Rajesh Premchandran. He's the Director and Head of Engineering Excellence at BT. Now, BT is a huge company here in the UK, so I'm really excited to hear about the challenges that they've faced transforming into a cloud-native business. So let's take a look.
BT is the world's oldest telecommunications company, dating back to 1846. Today, BT serves customers in the UK and in 180 countries worldwide. Our main activities are the provisioning of fixed-line services, broadband, mobile, TV products, and network services. We want to continue to lead in converged connectivity through radically simplifying our business, building scalable platforms for growth, and creating leaner business models. IT underpins this enterprise transformation, and technology modernization sits squarely with that change narrative. We use platforms such as Pivotal Cloud Foundry, now Tanzu Application Service, and Tanzu Kubernetes Grid to accelerate app modernization, enable DevOps, and change ways of working. In our attempt at app modernization, we've had several challenges. The issues haven't been technology. The challenges arise from our ways of working, processes, accounting policies, security postures, and even how we inventory software assets in the firm. These road bumps forced us to hit the pause button a couple of times and think about whether to pivot our strategy or persist. Today, I'm going to share 3 aspects of these internal challenges that the BT Tanzu platform team had, and how we either accommodated the existing protocols into our platform rollout or influenced change within BT so we could exploit the promise of something as game-changing as Tanzu. These 3 aspects are strategy, security, and people. First, let's talk about strategy. Our initial approach was to create an application platform for microservices, using only the Tanzu app service. This was good for those apps that used cloud-native frameworks such as Spring Boot. We reduced the time to deploy from 2 months to under 2 minutes. However, many of our teams wanted access to Kubernetes to run other workloads. They wanted to containerize existing workloads and leverage the scalability and configuration-based infrastructure management that Kubernetes offered. Like any enterprise who's been around as long as BT has, our estate is mostly brownfield. Relying on application refactoring into microservices as the only channel to realize benefits of a platform like Tanzu was clearly limiting. So we started using TKG to cater to that section of developers who wanted a Kubernetes dial tone. Listening to your dev team and understanding which feature set of a product they really want was a key learning for us. Next comes security. In the on-premise data center-based world, a lot of these security principles were centered around layer 3, with IP addresses providing service endpoint identity and a basis for routing. With a profusion of microservices, each with its API endpoint, our first challenge was getting our colleagues in security to agree to de-link applications and public IP addresses. Tanzu is a multi-tenanted platform which needs to interact with the rest of the BT ecosystem. With AWS being our choice of IaaS, we needed to shift thinking in terms of elastic IPs and REST endpoints instead of fixed IP to IP connectivity. Here we had to persist, as pivoting was against the guiding principles of modern cloud architecture. We worked with our leadership to influence 2 changes. Get our security team to focus on cloud through dedicated personnel aligned to IT dev teams, which helped us engage, educate, and empower. Second, hire cloud security experts to work with our security team in creating new policies that work in the cloud. There's much more to be done in this space, but we are persisting. Third, on the people front, we sensed a gap in understanding when it comes to cloud adoption, especially across SaaS, IaaS, and PaaS. Dev teams debated whether to go native with AWS or GCP or use Kubernetes on-prem or to leverage PaaS solutions. They also were not fully aware of shared responsibilities of managing infra as code or how their roles change when adopting the cloud. With a more DevOps model, their accountabilities did not end with a successful CF push. Day 2 ops had been outsourced, and dev teams needed a huge shift in thinking. Here, we had to pivot, and instead of letting them grapple with operating model choices, we adopted a more human-centric approach to educating teams. We sat down with the enterprise architects, took an inventory of all our applications, and classified apps into legacy, strategic, SaaS, PaaS, and IaaS. This was painstaking work, but it drove consensus around application treatment, educated teams on their roles, and provided simple heuristics for the complex op model choices dev teams had to make. The greatest benefit of this app classification exercise was eliminating scope overlap in our budgets and app modernization plans, allowing the PaaS team to focus on execution. Change is hard, but it is also a great educator. In our quest to overcome challenges, we've learned that our strategy and approach needed to be flexible in parts and relentlessly rigid on some principles. We pivoted on some, persisted with some, but in the end, what we always kept at the forefront as a compass was our developer-first principle. We chose to empower dev teams to make choices, get friction-free access to cloud services, and start innovating with incredible agility, all in the hope that we've created the solid foundation for BT's transformation strategy to execute at pace. Thank you, and have a great SpringOne 2020.
Thank you, Dr. Prem Chandran. BT is 170 years old. I guess that proves that you are never too old to innovate.
Absolutely, yeah. I like what they did there as well, listening to developers, putting them first, moving to DevOps, moving to microservices. I can imagine that was, tough yards, but it's clearly well worth it. So I'm really glad that Spring was there to help them and Tanzu was there to help them as well. That's great.
So who's our next speaker, Ben?
Well, next up, we have our good friends Chris Sterling and Bella Bai. Now, Chris Sterling is the Senior Product Line Manager for Spring Cloud Gateway, and Bella is a Senior Software Engineer, also working on Spring Cloud as part of the commercial team. Now, together, they've been working hard to try and remove that friction that Ajay spoke about yesterday that developers often feel with traditional API gateways by building something that's a more developer-focused alternative. So let's take a look. But first, a warning. This video contains unspeakable cuteness. And for once, I'm not talking about the presenters.
Hello, I'm Chris Sterling. I'm Product Line Manager for Spring Cloud Gateway.
Hi, I'm Bella Bai. I'm a Senior Software Engineer on the Spring Cloud Commercials team.
And over the past few years, we've been talking to customers about their API gateway needs and how they manage their APIs. And through those discussions, we found out that there was quite a few friction points for their application developers. So we created the Spring Cloud Gateway commercial product on Tanzu application service to support their needs. In the Spring team, we're very passionate about how application developers work each day. And so we're going to show you how Spring Cloud Gateway for VMware Tanzu supports their needs today and show you an early preview of how we're going to provide that same experience on Kubernetes. Bella, can you start us off with the basic capabilities of our Spring Cloud Gateway product on TAS?
Sure, happy to. Let's demonstrate Spring Cloud Gateway through an example that I'm personally passionate about, Animal Rescue. Here I have a simple React frontend app and a Spring Boot backend app that doesn't have any security configuration for authenticating users or requests. Let's see how Spring Cloud Gateway can help to secure them and tie them up. First of all, let's create a gateway instance. And while we're waiting for the gateway to deploy, let's take a look at the configuration we're using. This SSO block tells the gateway service broker to create a backing SSO instance for the gateway app to bind to, using the plan and identity provider I set here. I also set the count parameter to 2 in case there are too many adopters, then the requests will be load balanced between these two instances. Okay, the gateway instance is ready. Let's push the Animal Rescue application. Like I said earlier, the Animal Rescue app has a front-end web app and a back-end API. In the manifest file, we tell both apps to bind with gateway service instance we just created.
You may notice that there's no route configuration defined on the service instance yet. Both the front end and the back end have their own route configuration files that can be used dynamically to add their routes to the gateway. This allows each of the developers for the front end and the back end to have more control over their own route configuration and as the APIs change over time. Bella, can you show how these routes can be added to the Animal Rescue app?
Let's take a look at the route configuration for the front end. it defines two routes, one being public accessible and the other one requires SSL login. In the backend route configuration, there are three simple endpoints, one to retrieve all the animals, one to retrieve username, and one to manage adoption requests. Notice that the last two routes are SSL enabled, so Gateway will authenticate requests. Then token relay parameter tells Gateway to pass along the ID token, so the downstream APIs can consume information from the token. The animal rescue apps are ready. Now let's apply the route configuration. This script is essentially calling an endpoint on the Gateway service instance with a bound app ID and route configuration. Now it's finally time to see the cute little furry animals. All the adopt buttons are disabled because we're not logged in yet. So let's log in and let's try adopt Chocobo.
All right, now that you showed authentication, can you show us how the APIs can be authorized via specified user roles?
Let's say only users from the adopters group in Okta can perform adoption and others cannot. So for you, Chris, I have created an account for you in Okta as an auditor. Let's see if you can adopt any of these cuties. Okay, action forbidden. Request failed with status code 403.
Oh no, I really want to adopt San. Can you grant me permission?
Sure, just 1 second. All right, now you can put in a request for Sam. You're in the queue.
Some of our customers want to use their own generated client certificates to secure API endpoints. We've added the client certificate filter for this purpose. Bella, can you show us how this works in practice?
Absolutely. Let's say our partner site, animalrescue.com, wants to pull animals from our API, and here's the common name and fingerprint of their search. So we can add the client certificate header filter to the get animals route and update the routes again. Now, if we don't provide a cert, we get unauthorized. And if we make curl request with the correct animal rescue cert, then we still get a response back. If we use a different cert, say it's another cert with a different common name and fingerprint, we get access denied.
Thanks, Bella. For our customers that started to deploy APIs onto Kubernetes, they're looking for a similar application developer experience that we provide on Tanzu Application Service you just showed. Can you show an early preview of how we're going to deliver this on Kubernetes later this year?
Yeah. To focus on developer experience, I have pre-deployed our custom resource definition and the reconciler to manage that resource. And now let's create a Spring Cloud Gateway object and a load balancer service to get a public IP. This custom object is the equivalent of the configuration parameters in create service command on task. In this file, we're telling the gateway to forward all the requests to spring.io. The gateway deployment is ready. Let's try it out. Hey, it's working.
Great. Now that we have APIs configured on two Spring Cloud Gateway instances, one on Taz and the other on Kubernetes, let's take a look at our API Hub product coming later this year. Each of the tiles represent a gateway instance, and if we click into one of them, we can see the APIs that are configured on that instance. Here's the auto-generated OpenAPI documentation from the Animal Rescue front-end route configuration. Since it is auto-generated, this means you can add OpenAPI documentation easily to your existing APIs. Thank you, everyone. If you're interested in learning more about Spring Cloud Gateway, please check out the breakout sessions during the rest of the conference.
Yeah, thanks for watching and enjoy the rest of the conference.
Thank you, Chris and Bella. The gateway work and the API Hub stuff that you showed looks very interesting. If you want to learn more about API Hub, don't miss the session introducing Spring Cloud Gateway and API Hub for VMware Tanzu by Alexei Nestorov and Gareth Clay, happening later today in the architecture track. Ben, you have a talk later today, don't you?
I do. It's called Getting Started with RSocket, and it's on the beginner-friendly Spring track at 11:30 a.m. Eastern. So if you want to see a grown man cry, do come along to that, because you won't be disappointed.
I'd pay to see that. So see you there. I might even troll you on Slack. So who's our next guest?
Well, next we have Vijay Luthra. He's the global CTO of Northern Trust, and Len Hardy, the senior vice president of global IT, also at Northern Trust. And like Dr. Prem Chandran earlier at BT, Vijay and Len, they're committed to creating a frictionless developer experience for their developers. And they faced a different set of challenges to BT. So let's find out how they rose to that challenge.
Hello, everyone. I'm Vijay Luthra, and I'm the global CTO of Northern Trust. I hope you and your families are healthy and well, and I offer my condolences to all who have suffered a personal loss. It is a real pleasure being part of the SpringOne virtual conference, and given everything that has changed over the past few months, I feel really fortunate to be able to participate in this conference virtually this year. Northern Trust is a Fortune 500 financial services firm based in Chicago that primarily provides asset servicing, asset management, and wealth management services to institutional and high net worth individuals and families. We're one of the largest custodians in the country, with close to $11 trillion in assets under custody, over $1 trillion in assets under management, and close to $162 billion banking assets. There's a good possibility that if you have a retirement plan through your organization, that parts of the investment might be being managed by Northern Trust. Our mission within technology is to deliver IT capability, solutions, and thought leadership that are as distinctive as our brand and enable our business to deliver on the promise to efficiently achieve greater for our clients and stakeholders. Enabling our internal application developers with a frictionless experience is a key component of delivering the digital experience our clients expect. With our client benefits always in mind, we've had a bold vision of frictionless experience for our developers so we can rapidly roll out products and services to our clients. We've been on a cloud journey since early 2013 and have made some bold early bets on hyperconverged infrastructure, software-defined data centers, containers, and platform as a service, as well as CI/CD tooling. We've also made some big bets on an event-based fabric, as well as a service mesh, as we move towards a real-time agile enterprise. Our investments have allowed us to easily transition to a hybrid cloud architecture with microservices leveraging cloud-based services for compute, while data continues to securely reside in our private cloud. Our hybrid cloud architecture is the foundation for our digital transformation efforts. We have realized significant benefits as we look at key metrics like reduced time to market for environments by 70%, reduction in the number of resources involved in build activities by 80%, six-fold increase in production deployments, and 100% automated production deployments, and significant improvements in reliability and stability.
So, where are we today? We have a hybrid cloud model with a mix of on-premise, private cloud, and public cloud services. This allows us plenty of flexibility and more options for data deployment, while keeping client data protection as our top priority. We're what you would call a private cloud first shop, building on the investment that Vijay described. That said, we remain committed to our public cloud journey as well by thoughtfully and carefully utilizing public cloud capabilities for use cases like business intelligence and machine learning using non-sensitive data. We will have a hybrid cloud model for the foreseeable future. A critical factor in our success to date has been our product-driven approach to our private and public cloud capabilities. Let me tell you what I mean by that. We have named specific product owners who are responsible for interacting with our internal clients, the application development community. These product owners write the stories, they set the priorities, and maintain the backlog of new and improved capabilities. This really puts our developers at the center of what our cloud infrastructure team is working on. We need to provide cloud capabilities with the same mindset that we build client software. Listen to our clients. Give them the capabilities that they need to deliver business value while increasing speed to market through automating everything possible. At Northern Trust, the willingness to change the way our teams are organized and work together has been key to our success. As we move to the cloud, we continue to transform our organization by evolving from teams working in silos based on infrastructure technology to integrated teams focused on supporting and automating a specific business unit or platform. This has led to the reduction in some SLAs from days to hours. In order to provide the most stable, reliable, and automated platform for our developers, we are focused on maturing our DevOps and site reliability engineering functions and capabilities. When we brought in the Tanzu application service, we established an operations engineering team that was focused on developer productivity and speed to market. We hand-selected a team of individuals with a diverse set of talents, skill sets, and experiences. But the common thread was a developer mindset and the relentless pursuit of automation.
As we continue our cloud journey, most recently we made a major bet on the Dell VMware stack by consolidating our private cloud stack onto VxRail on Dell hardware, VMware Cloud Foundation, vRealize Automation Cloud, and Tanzu. A rich set of tools for governance and intelligent workload placement are part of the stack as well as developer-friendly tooling that exposes the platform as code for rapid deployments. This also lays the foundation for secure, scalable hybrid clouds.
Both private and public cloud platform adoption and developer productivity increases have been phenomenal. Over the last 2.5 years, our developer base on Tanzu application service has increased over 150%. During that same time period, the number of production services has increased almost 300%. And as Vijay mentioned, developer productivity has accelerated, with production migrations increasing 6-fold. Additionally, since the end of 2019, we have seen 9 applications move to production in the public cloud, supporting all of our business units and spanning multiple public clouds. Putting public cloud and Tanzu together showcases our hybrid cloud strategy. An example is a client-facing chatbot application using a public cloud bot service with machine learning, coupled with sensitive data on our private cloud, front-ended by data services running on Tanzu application services.
As I said in the beginning, we have a 130-year-old rich history of providing leading financial services to our clients globally by leveraging innovative technology. Our cloud journey has evolved quite a bit over the years, and so have our partnerships. However, our commitment to delivering products and services to our clients rapidly by providing a frictionless experience to our developers and product owners remains as important as ever.
300% growth in services reaching production, 150% growth in TAS platform adoption. These look like phenomenal developer productivity increases. Congratulations, Vijay, Lynn, and everyone at Northern Trust, and thank you for sharing your story today. So Ben, let's do some housekeeping. Can you please remind the folks how they can get involved?
Yes, absolutely. So get involved with us on Twitter. You can use the hashtag SpringOne to do that. We're looking very carefully at all those tweets and we love them. We also would really like everyone to sign up for the conference Slack. That's springone.slack.com, where you can then interact with the speakers of the various sessions that we have today. And if at any point you feel like you just want some time out, you want a bit of a break, check out the social track. There are some amazing things going on in there, and you're bound to see something different. So do call by and try that out.
All right. So thanks for the updates, Ben. I guess it's time to introduce our final guest.
Yes, it's that time. Final guest time. So our final guest today is the lovely James Governor. He's an analyst and co-founder of RedMonk. And RedMonk pride themselves on their relationship with developers, the fact that they understand developers. So they've really dialed into this kind of global developer community and the pulse of what's going on there. I'd advise everyone to really pay attention to this. The stuff that James says tends to be influencing developer CVs for the next couple of years, so it really is worth your time. Over to James.
Hi, I'm James Governor from RedMonk, and I'm super excited to be here at SpringOne. Why am I excited about Spring? Because RedMonk is all about developers. So, why developers, right? There's been a revolution in how IT happens over the last few years, where the developer is increasingly in control of decision-making. Obviously, you have top-down, but we're all about the bottom-up. And so what we look at is the kinds of decisions that developers are making, why and how they're making them, right? And so we're in this revolution where we've got like more self-service. We've got auto-scaling services so the developer doesn't have to spend all their time worrying about that. We've got rich ecosystems of services that they can bring together. We've got like less reinvention because somebody else has done the work to make the developer more productive. Why is that important? Because whether you're an enterprise, whether you're a SaaS company, whether you're a public cloud vendor, your success is going to be predicated on your ability to serve developers, serve modern developers, and help them to do their jobs more effectively. Because quite frankly, look, we're in a period of extreme transformation in all sorts of different angles and different focuses. And that's why it's so important to serve developers, serve them more effectively, and the platforms that are winning, that's exactly what we see. So we think about the cloud. We think about what's happening there. We've had a really interesting phenomenon, really grew up from containers. Obviously, Linux was the natural operating system of the cloud. But what happened was containers came along. It offered some advantages. Now, that only really became a thing with Docker because of that focus on developer experience. So Solomon was like, okay, look, I'm going to pull this stuff together and make a developer highly productive. They're going to be doing microservices. They're going to be doing CI/CD. They're going to be taking things. They're going to be throwing them away, spinning up new instances. And that whole package and everything required is going to be there for them as they do their software development. So, of course, you got this idea of like, do it on the laptop and then deploy it on the cloud. That's where Kubernetes came in. So this was great. Kubernetes was definitely a powerful way of taking applications that were built and orchestrating them in these distributed systems. But of course, there was and is and remains a fair bit of complexity there. So while the Kubernetes community is like, wait, okay, we need to take that, we need to simplify, we need to work on developer experience, we need to start thinking about a separation of concerns around platform and around services. At the same time, Amazon came along and like, great, we could take these containers and build something called serverless. So this idea of like functions that you could build and services that could be basically composed, a rich, as I say, service ecosystem. That's what happened with Amazon Lambda. And really, that is a profound change in terms of developers and productivity and them having to worry far less about the surrounding infrastructure for building that service, whether that be scaling a database, whether that be calling authentication. That is the fundamental change. And so now we've got two competing and increasingly collaborating models of the world. One is serverless and one is this Kubernetes world. And that's, I think, really where we are today. And let's think about services and let's think about serverless and moving forward from there. So serverless was an Amazon phenomenon. I've said that. And obviously they have all of these things that you can call all sorts of batch jobs within the Amazon services themselves. But what if you want to use something else? What if you want to use something like Auth0 for your authentication? Or do you want to use Algolia for text search? Or you want to use Cloudinary to manage your media assets, your images and your videos? How do we pull that together? Quite interesting that the serverless community began to call that model service full. So service full is a way of thinking about the world where you're not tied into one public cloud, where it's all about that developer productivity, where developers say, right, I'm going to pull together this application, rich palette of services, and I'm going to have choice. But also we may want to have some ability to have state in that. So where do we go from there? How do we manage that persistence? What do the platforms look like? Because certainly the sorts of organizations that have adopted Kubernetes, many of them are thinking about state. That is something they're worried about. How do we manage that? So there's an interesting model that, I just came across this. I wrote a tweet, and a guy called Mark Hinkle from Triggermesh said, wait, that's smokestacks. We've got service full, we've got mashable, we've got open, composable. He's a Kubernetes guy, so C is done as a K, and event-driven. That event-driven thing is something to remember, I think, because what we're talking about is more reactive programming models. That was a good term, but then, of course, it being a tech industry, somebody's going to come up with another idea, and I think someone that really nailed it was Bob Muglia in his work now at FaunaDB, where he called it client serverless. Why is client serverless resonating for me in this model that I'm talking about? Because frankly, we've got richer clients. I mean, we've had the JavaScript revolution in the front end, and sure, we've got mobile clients, but definitely we've got very, very rich clients, the interaction of these services at the back end. These services are managed and orchestrated by the front end as much as they are by that back end. This sort of gets back almost to a client-server kind of thinking, but as I say, of a rich set of services across a bunch of different platforms built by different folks. So let's talk a bit more about reactive and event-driven programming, because frankly, that is where this whole model really begins to make sense. And I think to me, that brings us around to Spring and where we are with Spring in 2020. So Spring has been a phenomenon for years. It's always been opinionated. It's always been about like taking some of those developer jobs that are hard and making them easier. Doesn't this sound like some of the things I've been saying? Making less yak shaving for the developer. Don't worry about the class names. Don't worry about the database. We're going to manage all of that for you. And of course, this evolution that Spring has been on, they saw microservices, they saw containers. And it's like, okay, we need to move to Spring Boot. We need to make that easy. And frankly, the programming model needs to support that. And that's reactive programming. And certainly for the modern Spring developer, that is absolutely how they need to be thinking about building apps. Because that's what we're talking about. What's the call to action? What are you here for? Well, I know what you're here for. You're here to learn. Because frankly, developers, you've got to keep your skills fresh. There are all these new platforms, all these new opportunities. And it's like, look, unfortunately, this year we can't be there in person. So we don't have a new Spring t-shirt. New skills, old t-shirt. That's what I want to see. Get your oldest Spring t-shirt, Interface 21, Spring Source, whatever it is. Why don't you wear it while you're learning? Put on the t-shirt, take a selfie, hashtag SpringOne, hashtag SpringT. I'd love to see it. I know the community would. See you then.
So there you have it. James brings our keynotes to a close. Thank you, James. And what a call to action. Go find your finished conference tees and share them with the rest of the community on Twitter using the hashtag SpringT.
Absolutely. I've got mine ready. I've got an old Cloud Foundry Summit from 2017. But also, you get extra bonus points if your conference tee's been around the block a few times. You know, if it used to be red and now it's a bit pink, then we want to see that. If you've done it on a hot wash and, you know, it used to be large and now it's small, then we want to see that as well. So, yeah, share away on Twitter using the hashtag SpringT. Let's see what you got.
All right. Before we go, here are a few reminders. First, take the survey. Share your thoughts on SpringOne 2020. Second, recordings will be available on the SpringOne.io website on about September 10th. And finally, join us for VMworld 2020 online from September 29th through October 1st. All that remains now is to say thanks to all of our main stage guests and all of our speakers here at SpringOne 2020. And of course, thanks to our brilliant sponsors who've gone the extra mile this year, and without whom none of this would have been made possible. Please take the time to visit the sponsors page on the website and request a meeting or join them live on Slack.
And finally, thank you so much for joining Brian and I and keeping us company for the last 2 days or so. And thanks very much for your participation. We love the community and we love the fact that you get so involved every year, and we really look forward to it. We hope that the rest of your day here at SpringOne is a good one, that you enjoy yourself, and don't forget, ask lots and lots of questions. So stay safe, take care of yourselves, and we'll see you next time. Goodbye.
Bye.